Good morning, good day, everyone. Welcome back to ECE Lab. So our topic this time around will be Triac and Diac. So Triac and Diac as one of the electronic components. We have several electronic components. So that we have studied and that we are still studying. So we want to study the behavior of Triac and Diac in a circuit. And when we say Triac is semiconductor materials. It's like transistor, though it's different from transistor. So is the class of Triac and Diac is thyristor. So there is transistor, there is thyristor. Transistor is for switching and amplification, but thyristor is for switching and controlling of circuit, controlling of power in the circuit. Especially Triac is a switching circuit and also is used to control AC source. It's used to control AC source in any circuit. That's a Triac. That's Triac. So, and it can conduct in several ways. Though sometimes Triac look like transistor. Though Triac is not transistor, is thyristor. The difference between the two. Let's see. I think we have one electronic material here that we can use to explain that. Look at it. We have thyristor. These are three types of transistor that we have. Thyristors. We have silicon control rectifier is a thyristor. Triac is a thyristor. Diac is a thyristor. These are thyristors, not transistor. So it's used to control AC source, AC power supply, and also it can also used as a as a switch. So, but we are talking about transistors. Transistors is used for amplification, and we have NPN, PNP, MOSFET, JFET, and all that different type of transistors. Though both of them look alike, but they will use it for different things. They are different, but how will you know them? So each of them have their numbers. I think each of them they have numbers to identify which one is transistor and which one is thyristors. But Triac and Diac and silicon control rectifier are thyristor. Now let's see what we have to do. These are the materials we are asked to get. We need AC source, we need DC source, we need capacitor, which is 0.1 microfarad, we need Diac, we need miniature lamp, we need Triac, we need 47 ohms resistor and 10 kilo ohm resistor. Then we need two switch, press button normally open, and we need single pole, single throw. So let's talk about the first one, which is Diac. This is Diac. Let me bring Diac. This is Diac. It looks like a resistor, but it's Diac. Resistor have different color on it, but Diac did not have any color on it. So it has no color, but it normally have number. But the common one is DB3. You see DB3 on it. It's different from resistor. That's Diac. So, and this is capacitor that we have capacitor here. This capacitor we want to use, we have positive, we have negative. This capacitor we want to use for this particular 0.1 microfarad capacitor. And also we are asked to find a Triac. Okay, this is Triac. We are going to use this Triac. Triac has 3 terminal. It has 3 terminal. You have MT1, that's main terminal 1, main terminal 2, and the gate. So if you look at it from inside here, so you can see that we have it there. You have gate here. So then main terminal 1 and main terminal 2. Gate and main terminal 1, they are together. Main terminal 2 is separate and is very thicker. So this main terminal 2 is one that will control the AC source. So the gate and MT1 will control DC source. This is the gate of the Triac, and this is the MT1, main terminal 1. They are together to control the DC source, and we have MT2 to control the AC source. This is the Triac. That's Triac. And we also have to find switch, press button normally open. So this is the switch that when you connect it to a circuit, it will not on until you press it. And when you press it down, it will on. When you remove your hand, it will switch off back. That's press button. That is what we have here. This is the switch. Press button normally open. So it's normally open like this. It cannot power. When you use it to connect any circuit, it will not on. But when you press it down, the circuit will on. When you remove it, it will off back. It's normally open. Then we still have another one we call press button normally close. That one is normally closed. It has been closed. When you connect it to a circuit, the circuit will on. But when you press it, it will off. When you remove it will on again. That's press button normally closed. But this one is press button normally open. It's open like this. When you connect to circuit, so until when you press it, that the circuit will on. When you remove your hand, the circuit will off. We can use this kind of switch for our gate, our doorbell switch. You can use it. When you press it, the doorbell will ring. So when you remove your hand, the doorbell will stop ringing. So you can use that one. Then we have single pole, single throw switch. I think this is the single pole, single throw switch. Single pole, just one pole here, just a line pole. So if it's two pole, I'm going to have one here, one at this side, one here, one here. It's going to be 4 terminal, two pole. But this is just one pole, single pole, single throw, 1, 2, just a throw, not 2 throw. That's that. Those are material we have to find. Let's look at what we have to demonstrate. Objective A: demonstrate by the directional conduction of a gated triac. This is the circuit given to us. So we are going to use 2 sources, DC source and AC source. We connect our triac. We are going to use a lamp. We are going to use miniature lamp, and this miniature lamp, we are going to use it. Then let's go to and we need a 47 ohm resistor. 47 ohms resistor, something like this. This one is 50, but we can still use it as 47, because when you measure it with multimeter, to give you something like 47, 48 or more than that, so because of the tolerance and efficiency of that resistor. So then we need 10K. This is 10K resistor. So we have all those. Let's now go to what we are asked to do. So they say adjust the main terminal voltage. Okay, we have to connect the circuit as shown. Let's connect this circuit and see what we have to do. So the first thing is to connect our AC source. So let's connect. This is our AC source, Triac. We use this one for AC source, variable AC source. We're going to use this one for variable DC source. These are variable DC. That will give us variable value for AC source. So we're going to use these two. Now let's connect our AC source to our circuit. On our breadboard, let's use this up for the positive terminal. Let's use this one for our ground or negative of the source. We have connected that one. So then what we need is miniature lamp to the positive of the. We have our miniature lamp. Miniature lamp does not have any terminal, positive or negative, but a LED is one that have positive and negative. But miniature lamp did not have positive or negative. Connect one of the leg of a miniature lamp to the positive as shown from the circuit. The other leg, so we are going to put it down and connect the MT2 of transistor of our triac with it. So we are going to, let's put this one on, let's put it somewhere here. Let it be on ground. Okay, let's use this. So while we use up, let's use down for that leg. Let's use down so that we're able to connect. So now our triac now. So the triac, this is MT1 and the bay and the gate. So MT2 is up. Let's see MT2 here. This is MT2 here. This is MT2, the MT1, and this is the gate. This is the gate of it. MT2 connected to our miniature lamp. We have connected that one. Okay, let's put this. Let it come down. Let's put this. Okay. Let's just place this leg or anywhere so we might measure. But what we need is that we have to make sure that the MT2 main terminal 2 of our triac is connected to the lamp, one leg of the lamp. We have done that. So we have done this now. So we have done that. So we've connected this one to the lamp. Now it remains the gate and the MT1. MT1 to the ground, to the negative of our positive. So let's connect it. This is the negative. This is the MT. This is the gate. This is the MT1 to the ground. This is the ground connected. That's MT1. Let's place down the gate down. But this is MT1 connected. We have done that. The gate now will need 47 ohm resistor. Connect with the base of the gate. Let's use this one as our 47 ohm resistor. Connect it to the base. Connect it to base of our triac, sorry. our triac done. So we have connected the other side of the. Okay, let's place down the other side of that resistor. We've placed it down. So we have connected that one like that. So we have connected the resistor with the gate and the empty one to the ground. We've done that. Now, what do we need now? What do we need now is we need a switch. Now look at it now. This is press on switch. That's what they use here. Press on switch. So as press button normally open, this kind of switch. We'll connect one end of the switch to the resistor, the other hand to. So we need DC source here. That means we need DC source here. We need DC source here. Let's do that. Let's connect our DC source first. So let the positive of the DC source be here. Then let the negative of the DC source be here. So we have it there. So it's connected. So this is our DC source. We have connected this on the. So now if we look at the 47 ohm resistor, so we need a press button. One terminal connected to the resistor, the other one to the positive of the DC source. Let's do that. This is our press button. Normally open. So let's connect it. We have connected one hand to the resistor and the other leg of it to the positive of the DC source. So this circuit diagram is what we just did. Now that's the circuit. That's what we had to connect. We've done everything has been connected. This is the circuit now. It's what we just connected now. Adjust the main terminal of voltage. That means we need, for our AC source, we need 6.3 volts. Then for our DC source, we need 6 volts. So that's what we have to do in here, B and C. So let's go and do that. Let's do that. So I want to use meter on this one because my AC source did not have meter to know the value of voltage that I'm going to have on my. So I want to use meter to measure my AC source. To measure my AC source, I want to use multimeter for that to measure my AC source. But this one have DC source have a meter on it to measure to have 6 volts. Let's see. Let's have our 6 volts from our DC. Okay. Let's see. Okay, let's leave it at that. So let's see from our AC source. Let's have 6 there as well. Let's see. Do we have? Okay. Let me hold it there. Okay. Let's see. Oh, we need 6 volts from there. We need 6 volts, 6 volts, 6 volts. So see from the knob now. We are controlling it from up here. We are controlling that from this up, the knob to. So now we have. Let's see now. We have 6 volts. We have connected 6 volts to each of them. So though it will be coming up because of its AC source, it will be coming up and down. But we have both of them to be 6 volts there. What's the next thing? We are asked to. This is the question given to us. They said D. Depress and hold switch 1. Does the miniature lamp light? Let's see. You can see now when we depress. So let's see. Let's press it now. Have you seen it? Let's leave it. Let's press again. Let's leave it. Let's press again. That's the function of Triac. So once the gate is triggered, so it can be able to. Triac cannot control AC source until there's a DC source that will trigger it. So it requires a DC source to trigger it at the gate before it can transfer the AC source from main terminal 1 to main terminal 2. So that's the function of the AC source. That's what. Depress and hold switch 1. Does DS1 light? Does the miniature light? Yes. So release S1. Does DS1 go out? That is our miniature lamp. Does it go out? And you can see that it go out when you press on. When you release off, it go out. Why is it necessary to hold S1 depressed to cause DS1 to light? Why must we hold on? That's what they ask us. Why must we? Because we have a DC source from there that is feeding the Triac to feed our load. But why must we hold the switch? Why must we hold it before we are going to have our load? Because Triac cannot control a AC source without a triggering voltage from the gate. It's the gate that will trigger it to operate. Once the trigger voltage or current is reduced, so Triac will not function again until it has a triggered voltage. So that's why we must press it down. That's what they asked us there. So now let's see what the next thing. Connect the oscilloscope across DS1 to monitor the load voltage. So depress and hold S1 load voltage waveform to complete the sine wave. Release S1. We also use oscilloscope to measure the load voltage on this. Let's connect our oscilloscope and see what will be the voltage from that side. Let's see. So this is our transistor. This is our LED. That means one leg is down here. That means we need to let me get one jumper wire from here and a cutter. Let me get jumper wire and cutter. So let's bring those legs out. So for you to make it easy for us, let's bring it out. Because if you do not bring it out, it might not be easy. So let's bring it out. Now you can see now what I want to do is that I want us to this is our miniature lamp. They say we should put oscilloscope to it. To one of the, you can see that MT2 is the output. We put our oscilloscope positive, negative to the ground. So we will bring out the ground from the negative. This negative of the oscilloscope, positive of the oscilloscope, from the one terminal of our. So let's now see it on our oscilloscope. Let's see what we are asked to. Let's see what the thing will give us. Let's auto-set it and see. You can see it tries to give us this waveform. This is the waveform it gives us. Let's measure. We are asked to measure. Okay. So what do we are asked to adjust the. Okay. Let's see what we are asked to measure here. Let's see what we are asked to measure. Adjust the terminal. Okay. We said depress. Okay. Connect the oscilloscope. Monitor the load voltage. So load voltage. Let's see the load voltage. Load voltage is we have maximum 0. Or we can use that amplitude, or we can use that of our peak to peak value. That's the voltage, peak to peak value for the voltage or amplitude. Let's use the that amplitude is a 16.64 volts. That's the voltage. So 16.64 volt, 16.64 volt. Let's note that one down. That's 16.6 amplitude 16.6 volts. Yes, 4 is not there. 16.6. Let's see. Have you seen all the value? These are the value that the oscilloscope gives to us. So 6.6 volts from there. They now say depress and hold switch endwise. The load voltage waveform complete the sine wave. It has complete the sine wave. Even it's complete the sine wave. It's complete sine wave. Yes, it's complete sine wave from there. So that's that. Now we are done with this. Reduce your voltage to 0. We've done that. So now demonstrate the 4 triggering mode of a Triac. Triac has 4 triggering mode. That means Triac can operate in 4 different ways. We have AC and DC source. So if the AC source is, in AC source we have MT1. So MT2 we have DC source. When we change the polarity of either of the two, either AC or DC source, so Triac will still operate. That's what they want us to verify. That we're going to use this table. When our MT2, so MT2 is fed by DC source. Exactly now. So we want to see when MT2 is positive and gate is positive, what will be the polarity of the gate current. And with that, when we change the polarity of MT2, which is DC source, so are we going to see have the output? Does our bulb are we going to have our bulb to be light again when we change the polarity? So, and we have four quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So 4 ways. So when we interchange the terminal, let's see what we have to do. So now we have to change this circuit now. Change the circuit to the diagram shown below, this one. Then it's like we have a switch here, single pole, single throw. This is the same circuit, it's just that they break it here. So let's break that circuit. We'll remove the positive end of the lamp and put switch to it, and the positive of the source. Let's go and do that. So let's remove, this is the lamp, the positive end of the lamp. We're going to remove it. We're going to put a switch. Let's put a switch to the positive. Let's put switch. We're going to put our switch here. So enter. Then let's put that switch stay somewhere here. Let the switch stay somewhere here. Now that we have it, then the lamp, the miniature lamp, the other leg. So we now connect it with. We're going to connect it. Okay, it's done now. So we've connected the lamp with the switch. We've used switch to break the voltage from the AC voltage. We have used switch to break it like that. So we have used switch. That's that about that. That's that about that. Okay. Now let's now see what else we are asked to do. We have changed the circuit to this. So let's say procedure 2, procedure 3, procedure 4, 5. Let's see the procedure, what we are asked to do. On the close switch S2, depress S1 momentarily. Does the light on? Well, let's see. We have to close this switch. We have closed it. So this is one close. Then let's now depress this. You can see when you are depressing it, what is happening? We are having light. So close switch S2 and depress S1. Does the miniature lamp light? Yes. Look at your circuit and then record in table 81 the triggering mode of Triac configuration. So the control refers to the main terminal voltage and characteristic curve. Okay, opens. Okay, let's see now. You can see that this is our MT2. This is our MT2. And MT2, there you have positive. You have positive. Positive. Now let's go. We have to follow this quadrant. The first one, you can see that our MT2 is towards the positive voltage. When we have it to be positive, so our MT2 is positive. Okay, this is our MT1. MT2 is positive from here. And you can see that the gate is also positive. We have it to be positive. So when we have MT2 to be positive, this is MT2 positive. So you can see that, and this is our gate, the positive also. That means the current will flow from MT1 to gate. That's the positive. The current will flow forward. So that's the positive. So we are going to have positive current because the current will flow from here. Will flow from gate to MT1. To flow from the gate to MT1. This is the gate to flow through to MT1. If we have our MT2, which is this, to be positive, and we have gate polarity also to be positive, so we are going to have positive current flow. So now that's what we are asked to do in this step. So in this step, said close this. Okay. Now triggering mode Q1. That's what we asked to do in step D. Look at your circuit and then record in table 1 the triggering mode. The first triggering mode is that we have our MT2 to be positive and gate to be positive, and we have our light to be on. In that case, we still have. Look at it now. Let's now on it when we have it. So you can see that we have our light to be on when you press, when you press on, when you leave off, when you press on. So that means it can be triggered if you have MT2 to be positive from the DC from AC source, and from DC source if you have your gate to have positive terminal. That means you are going to have positive current. The current will flow from the gate to MT1. MT now will now trigger MT2. So that's that. The second one, let's see what we have to do next. Reduce the gate to zero, gate voltage to zero. That's, and then reverse the polarity of the gate voltage by reversing the power supply lead common to. That means our DC source, we have to reverse it. Our DC source, let's reverse it. Let's change the DC source. Positive will now come to the negative negative point, and then negative will go to positive point. Let's see, we have interchanged it. We still have our MT2 to be positive, but our gate has been changed to negative. The gate polarizer has been changed to negative. So it means that if the negative polarity of the gate voltage is negative, that means the current also will be negative. And let's now see now if we are going to have, if we see, you can see that it still operates. If we are at that, it still operates. Despite the fact that we change the polarity of the DC source, we can still have Diac to be triggered. That's for the second quadrant. That's the second quadrant. So adjust the gate 6 volts, close the switch and repress momentarily. Record does the momentarily. DS1 should light and it's light for our D. Let's go to E. Record 8 to E1 data for this triggering mode, and we have recorded it. That's our quadrant 2. Positive for the MT2 and negative for the gate voltage, which is the DC source. We've done that. So open F now. Open switch 2 and DS should go out. We have opened and it go out. Then number 4, reduce the main supply to 0. Now 4B now. Reverse the polarity of the main terminal voltage by reversing the power supply lead connected. So let's go to the main terminal. Now we are now asked to reverse the main terminal. That is main terminal from the AC source. We want to reverse that one as well. In that case, that means our main terminal, when we have it to be negative, exactly now, and we still retain this one as negative. So that means the gate polarity will be negative. This situation now, this quadrant 3, so we want to implement it and see if the track will still operate. Let's interchange. So let's remove the positive of the main terminal, change it to negative, change positive to negative, and the negative to be positive. We have interchanged the terminal of the main terminal, MT2. This is MT2 that supplied the AC source. We have interchanged it. Let's now see if the thing will see if the track is still going to deliver load to our bulb. Let's see. You can see that it's still working. You can see if when you depress to on, when you release it, when you depress, when you release. So at third quadrant, you can see that reverse the polarity. We have done that. Then adjust the terminal output to 6 volts. We have 6 volts already. Close switch 1 and depress we've done that. That's what we just did now. We depress and DS should light and it's light. Record data for that's what we have in our third quadrant. We have it on the third quadrant. Negative from main terminal polarity, that's AC source, and negative DC source. So we still have negative current flow through, because current will flow from the terminal, from the gate, from the terminal 1 to the gate. It will flow back. That's negative. It will flow back from the gate to terminal 1. So current will now flow from terminal, but terminal 1 is now positive. Terminal 1 is positive now. So the current will flow from terminal 1 to the base. It will flow back. That's negative. The gate polarity will now be what? Will now be negative. That's why gate polarity is negative. So let's see what we have to do again. Reduce the gate voltage to 0. Reverse the polarity of the gate voltage supply. DC source now, we have to reverse it back and have 6 volts. And see, let's reverse it back and see what will happen. This is our gate voltage. The DC source is one that, this is our gate. So let's now reverse, let's return, let's put the negative to the ground here. Then we'll have our positive here. It means that when we still have negative at the main terminal, the AC source, and our DC source, the positive is we have positive terminal from DC source, which is the gate source. So then it means that the current will now flow from the gate to the main terminal because we have positive terminal at the gate. So current will flow from positive down to the main terminal. That's we are going to have positive gate polarity current. So it will be positive. Let's now see if that Triac is still going to operate in this condition. Let's see. Let's see if it's going to operate in this condition again. Let's see. You can see that it still operates in that condition. Have you seen it? When you on, off, on, off, on. So that means, so it's on. Record, we have recorded it. Then F, open, switch, and reduce all voltage to 0. Look at the record. Look at your recorded data of table 8 to 1. Will you say Triac has 4 separate and distinct triggering mode? Yes. So this shows that Triac has 4 separate triggering mode. It can operate in either polarity, different polarity from the main terminal, and or any different polarity from the gate terminal. Gate terminal is fed by the DC source, while main terminal is fed by AC source. That's that about that. Now, the next thing we want to do now is we want to demonstrate bidirectional operation of diac. We want to see diac, how diac can operate in any direction, so in both directions, and we want to see, so from the diagram, from the practical that we want to construct. Let's see now. Examine the circuit shown in Fig 8 to 5. This is simple addition oscillator. So we have to connect this circuit now. So we have been given the circuit. We need a DC source, 40 volts, connected with 10 ohm resistor, connected with capacitor, and we need diac. So we have to connect our oscilloscope across that diac and see the operation. Let's do this one first. Let's connect the circuit. So we need 10K resistor connect to the positive of our DC source. This is our DC source. Let me connect this is my 10K ohm resistor connected. Okay, that's done. So I've done that. So now the other side of my resistor, we need capacitor. The positive side of it, this is the positive, this is negative side, will be connect. We need to connect it. I have to connect it with that. Then connect. We have connect that one to our 10 ohm resistor. Then the other hand to the ground. The other hand of the capacitor, so to the ground, so to the negative of the source. Done. So we have done that. Then we need Triac. Let's use this Triac. This is Triac DB3 Triac. So let's use it. So we have to connect it with the positive of the capacitor and the resistor. So then we now bring that diac we connect the other side of diac to the ground. That means we'll come here to the ground. So this is it. It means at a point we have resistor, capacitor, and diac, so connected together. So you see from the circuit, we have at this point we need a resistor, the capacitor, and the diac connected together. So we've done that, and the other side of the diac connect to the ground. Also the capacitor to the ground, to the negative of the. So that's what we've just done now. So this is the circuit. So you can see that it's a very simple circuit. That's what we are asked to do. So then we need to connect our oscilloscope now. So we have positive. Connect positive to the upper part of that diac. So we have to connect it. So we connect. Let's connect our. Then let's use one to jumper wire to bring out the connections, all these connections. Let's use this one to bring it out. Oh, no, there's no need. I think what we need is even this one. We might not need this one. Let's see if we, so this is the negative of our oscilloscope. Like we can put it here to the ground. This is the ground. Let's see. It has been connected, and let's put positive to the junction. I think the thing has already, that's what we want. So we'll connect positive from the circuit. So the positive of the oscilloscope to the top of our diac. So we've done that, and the negative side of oscilloscope to the ground. That's what we just did now. So what we have to do, I just pass us to 40 volts. So momentarily ground the oscilloscope virtual input, trace the center, then let's see, measure the plus peak waveform across it. This is just the, we have to measure the peak waveform and then the amplitude of the waveform. That's what we have to do here. Let's see, let's adjust, let's have 40 volts. Let's see, let's have our 40 volts DC source from there. Let's see. Okay, let's give it that 40 volts. So let's see what we are going to have from our oscilloscope. You can see now. What do we have from our oscilloscope? Let's see. You can see we have exactly the sawtooth waveform. We are expected to, this is what we are expected to have. Sawtooth waveform from that from Diac. This is what you're going to give us. And we need, let's measure the amplitude. The amplitude there, the amplitude is 22.2 volts. Look at all the value for that waveform. Those are the values for that waveform. We have to, in some practical, we say find peak to peak value is there. There's also peak to amplitude value is there. Frequency, any parameter. Those are the parameters for that waveform. Those are the parameters for the waveform that we have on that screen. But as far as this practical is concerned, we have to find amplitude, to write down the amplitude of the, and that's what we have, amplitude 22.2 volts. That's what we are asked to do. Let's see what next. They said, okay, amplitude we are going to have 22.2 volts. That one is done. D, the 4D now, I mean 6D, sorry. Reduce the power supply to 0. Reverse the polarity of the power supply connected to your circuit. Put power supply 40 volts again. Is the polarity of the sawtooth inverted? I think we have seen the, let's see the waveform very well now. We are now going to interchange the terminal and see how the waveform will look like. I hope you are considered. Let's go and see now. Let's see the waveform now. Let's see the waveform. Have you all seen it? See, this is the waveform. So let's now see what will be the, when we interchange the terminal. Let's go and interchange it and see what we are going to have. This is our source, the positive here, negative here. So by the time we now interchange, let's see what we are going to have. When we put positive to where we have negative before, then positive here. So negative to where we have positive before, and the positive to where we have negative to the ground. We have interchanged. Let's now see from the, let's see, let oscilloscope give us now. Can you see now? You can see now that the waveform has been inverted. It has been inverted. When we invert the, when I look at the waveform very well, that's the waveform. That's what we get when we interchange the, so we have it to be inverted. So now reverse the polarity of the power, we've done that. Adjust the power supply, we have done that. Is the polarity of the sawtooth inverted? Yes, you can see from the screen, it's inverted. Does this mean that diac is conducting in the opposite? That's it. It means that diac can conduct in both directions, in two directions. It will conduct. Measure the peak of the waveform. Measure the peak of the waveform as in step C. Let's see the amplitude for this one now. Let's measure. Let's see the measure. Let's see the peak. You can see now that's the value for the inverted waveform. So anything we have to, if we have to find peak to peak, we have to find amplitude. Amplitude is 19.6 volts. So we have peak to peak 23.8, frequency 625.3 hertz. So any value we are asked to find. So this oscilloscope will give us value parameters for the waveform. So that's about that. Let's see what we have to do again. So now we have done this. I now is the breakover voltage approximately the same voltage in both directions. It's nearly the same, though not exactly the same, but nearly the same. 19 and 20 something, so nearly the same. This power supply to 0, so that's that about that. We are done with that's what we are asked to do in the practical, to study the behavior of the practical. We want to study, that's what we are asked to do. So to study the behavior of the electronic component, the diac, and the triac. No, we have studied transistor. So I told you earlier when we are doing our discussion that we have different electronic components that we need to study in this course. So we have studied diode, we have studied transistor. So now we are studying diac and triac. So next class, so let's see what we are going to pick something else and discuss about it. Thank you so much.